Hello and welcome. Today we're diving into something really cool, a powerful methodology for creative problem solving called TRIZ. It's basically a systematic way to innovate that can turn what feel like impossible challenges into these really elegant solutions. And honestly, it might just change the way you think about inventing forever.
You've totally been here before, right? You try to improve one thing, and it just automatically makes something else worse. Maybe you're designing a product, or trying to make a process at work more efficient, or even just fixing something at home, and you hit this wall. It's a contradiction that feels like there's no way out except for some messy, unsatisfying compromise.
So, in the world of invention, there's a name for this. It's called an engineering contradiction. Think about an airplane wing for a second. You want to make it larger and more rigid, for strength. But adding more material makes it heavier, which is a huge problem for a plane. That is the classic trade-off, right? The compromise that so often leads to results that are just meh. But what if you didn't have to compromise at all?
Well, this is where TRIZ comes in. It's a Russian acronym, and it stands for the Theory of Inventive Problem Solving. It was developed by a guy named Genrich Altschuler after he analyzed tens of thousands of patents. And he built it on this fascinating idea that inventive problems, and more importantly their solutions, actually follow predictable patterns. It's like a secret weapon for resolving those stubborn contradictions.
All right, so here's our game plan. We'll start with the core theory behind TRIZ. Then we're going to explore 5 really powerful tools from its set of 40 inventive principles: segmentation, taking out, local quality, asymmetry, and merging. And then we'll wrap up by seeing how you can slot this whole new mindset into your own problem-solving toolkit.
Okay, so your standard engineering approach usually involves finding a middle ground, right? Make the wing a little bigger but not too heavy. TRIZ just completely rejects this idea. It pushes us to find the ideal solution by getting rid of the contradiction itself. It forces you to ask, how can we make the wing stronger without making it heavier? And that shift from just compromising to creatively resolving the problem, well, that's the heart of real innovation.
Let's grab our first tool. This is principle number 1, segmentation. Now, this is just one of the 40 principles, but its core idea is so simple it's almost deceptive, but it's incredibly effective. It's all about breaking things down. So, instead of dealing with one single monolithic thing, segmentation asks us to break it into pieces, and these examples show exactly how it works. You can divide a whole system, like going from one giant mainframe computer to a whole network of independent PCs, or you could make an object easy to take apart, like modular furniture, or you can just increase how fragmented it is. Think about replacing a heavy solid window shade with lightweight adjustable Venetian blinds. It's brilliant.
Okay, so we've seen how breaking things apart can help. But what if the solution is to remove just one specific part or property? Well, that brings us to our second tool, principle number 2, taking out, or sometimes it's called extraction. The idea is to pinpoint an interfering or annoying part of a system and just get rid of it.
A perfect example is an air conditioner. What's the contradiction? You want nice, cool air inside your house, but the process of making that cool air generates a ton of heat and noise. So, what's the solution? You take out the hot, noisy parts, the compressor and the fan, and you put them in a separate unit outside. You've literally separated the essential function from its undesirable side effect.
From taking things out, we now move to treating what's left with some special care. This is principle number 3, local quality. It tells us to stop using a one-size-fits-all solution. Instead, you create the ideal local conditions for each specific part. I absolutely love this quote from the source material. Make each part of an object function in conditions most suitable for its operation. And this image here shows the concept perfectly. So the problem is a cart that needs to work underwater, but its wheels work best in air. The solution isn't some crazy new kind of wheel. Instead, look at that little bubble. The system provides air only where it's needed, creating a perfect local environment just for the wheels, while the rest of the cart is happy to stay in the water. It's genius.
Creating that special local condition is really a form of breaking uniformity. Our next principle, number 4, asymmetry, takes this idea and just runs with it. We often think of symmetry as a good thing. It's balanced, it's stable. But in the world of invention, intentionally breaking it can unlock powerful new functions.
Think about it. A symmetrical object, like a perfect sphere, often behaves the same way no matter what. But an asymmetrical object can be specialized to interact with its environment in a specific and much more effective way. The airplane wing is the classic example we keep coming back to. If it were symmetrical, it wouldn't generate any lift. It's that very asymmetry, the curved top and the flat bottom, that creates a pressure difference and lifts a massive plane into the sky.
So if breaking symmetry is powerful, what about intelligently putting things back together? Our final principle for today is number 5, merging. And it's the perfect counterpart to where we started. If segmentation is all about taking things apart, merging is about combining them, either in space or in time, to create some amazing new efficiencies.
So, there are two main ways to think about this. You can merge things in space, like putting electronic chips on both sides of a circuit board to basically double the density, or you can merge actions in time. A mulching lawnmower is a perfect example. It performs a second operation, fertilizing, at the exact same time it's doing its main job of cutting the grass. So, here's the crucial point. We've just scratched the surface. These are only 5 of the 40 inventive principles that make up the entire TRIZ framework. Each one is like a different lens, a whole new way to look at a problem to find a non-obvious, truly innovative solution.
So what does all this mean for you? How do we take these principles and actually turn them into a new way of thinking? Let's bring it all together.
Look, the most important thing to take away from this is that innovation doesn't have to be some random stroke of genius that just happens. TRIZ shows us that it can be a structured, repeatable process. By identifying that core contradiction in your problem and then applying these proven principles, you can move way beyond simple trade-offs and discover truly inventive solutions.
So remember this powerful new toolkit we've just put together? The next time you're stuck, ask yourself, can I divide this problem up with segmentation? Can I separate a key part with taking out? Can I optimize just one piece with local quality? Can I specialize a shape with asymmetry? Or can I combine functions with merging? The next time you face one of those challenges that feels like a trap, I want you to ask yourself, what is the real contradiction here? And which of these principles, or maybe one of the other 35, could help me resolve it completely? So, what impossible problem are you going to solve first?